In this lesson, we are going to look at angles that are formed by parallel lines. Our goal is to prove properties of angles formed by parallel lines and a transversal and use these properties to solve problems. So another type of angles that we have are called alternate interior angles. And if you remember in the last lesson, interior means they're in between the parallel lines. Alternate means they are on opposite sides of the transversal. Vertically opposite angles we talked about briefly in the last lesson. These are angles that are located directly opposite each other at a common point. For example, angle AEC is vertically opposite angle BED. Those are the ones that are highlighted in blue. And angle AED is vertically opposite angle BEC. And those are ones that are highlighted in black. Vertically opposite angles are equal, and it does not matter whether you have parallel or non-parallel lines. They will always be equal. We want to make a conjecture that involves the interior angles formed by parallel lines and a transversal. And we want to prove our conjecture. If you think back to the example we did in the previous lesson, where we wrote down all of the measurements of the angles, try and remember what the measures were of your interior angles and how they might relate. There are actually two conjectures that we can come up with. The first one is that when we have parallel lines, the alternate interior angles are equal. So that's the conjecture I'm going to make. Now we have to prove that it is true. And a proof has to be true in all cases. So we can't just assign numerical values here and say that because we've done the measurements, this is true. We have to prove it for all cases. What we do know is that corresponding angles are congruent. So we can start by angle 1 is equal to angle 2 because these are corresponding angles of parallel lines are equal. And that is something we determined last day, and it is a fact. Corresponding angles of parallel lines are equal. So we know that, we can state that. What we also know is that vertically opposite angles are equal. So angle 1 equals angle 2 because vertically opposite angles are equal. And this is true in all cases. So these are not just true statements for this particular problem. They are true all the time. Now, if we have stated that angle 1 equals angle 2 and angle 1 equals angle 3, we can then say that angle 2 must equal angle 3. And here are alternate interior angles. And the reason we can state this is what's called the transitive property. It's like you're transferring from one statement to the other. We said 1 equals 2, we said 1 equals 3. We have to then be able to say 2 equals 3. And the property is called transitive. So we have now proved that alternate interior angles are congruent. And we could have done the same thing with 4 and 5 had we labeled a corresponding angle and a vertically opposite angle. We would have been able to get to the same ending. So therefore, another property we now have is that if you have parallel lines, the alternate interior angles will also be equal to each other. Now, I had said there were two conjectures that we could make here. So the first one we made was for the alternate interior angles. But we also have another set of interior angles. And these are called same side interior. And the conjecture that I'm going to make is when we have same side interior angles. Now these ones are not equal. If you think back to yesterday's, or if you even look at them, you'll know they're not equal. But what was the relationship between them? And what I'm going to say is when we have same side interior angles of parallel lines, they will be supplementary. That means they will add to 180 degrees. And now we need to prove this. We're actually going to drop this down so we can see it. So what I want to do is I want to prove that angle 3 and angle 5 add up to 180. So what we have to do is we somehow have to get to this point. Well, what do we know for certain? We know that angle 1 equals angle 2 because corresponding angles of parallel lines are equal. We know that. We also know that angle 2 plus angle 5 will equal 180 degrees. 2 and 5 form a straight line right here. Angle 2 and angle 5 form a straight line. So we know that. We can use the two pieces of information we already have. Angle 1 equals angle 2, we know that. Angle 2 plus angle 5 equals 180. So if 1 equals 2 and 2 plus 5 is 180, angle 1 plus angle 5 must also be 180 degrees. And that we can just use by a substitution or transitive property. So we've taken what we know in step 1, we've substituted it into step 2 to come up with step 3. So now we know that angle 1 plus 5 is 180. What is something else we know? Remember, our ultimate goal is to show that 3 plus 5 is 180. We also know that angle 1 is going to be equal to angle 3 because they are vertically opposite angles. And if 1 is equal to 3, and in step 3 we said angle 1 plus angle 5 is 180, we can now use substitution again to say angle 3 plus angle 5 equals 180 degrees. And therefore we have shown that same side interior angles are equal. We have proved it, and it would be true in all cases. Alternate exterior angles are two exteriors, so two angles that are outside of the parallel lines that are on opposite sides of the transversal. So Naomi made the following conjecture. Alternate exterior angles are equal. Prove this conjecture. So the first thing we are going to do is we're going to actually need to draw a diagram so that we can work off of it and prove it. So I'm going to draw two parallel lines, and I'm going to draw a transversal. And because I'm not sure which angles I'm going to work with, I'm going to label each angle. So now let's find a set of alternate exterior angles that we want to prove to be the same. We can either choose 1 and 8, or we could choose 2 and 7. So if I'm going to choose 1 and 8, ultimately I want to work to the fact that angle 1 is going to be the same as angle 8. So there are a couple of ways that we could get there. Think about what we already know. Think about what we know about vertically opposite. Think about what we know about corresponding. We already know angle 1 equals angle 4. And we know this because they are vertically opposite angles. And they are equal. We have parallel lines, So we know that 4 has to be equal to 8 because these are called corresponding angles of parallel lines are equal. So we've said 1 equals 4, 4 equals 8. 4 is involved in both cases. So we can say angle 1 equals angle 8 by our transitive property. We're just transferring the information. And we have now proved her conjecture to be true. Angle 1 and angle 8 are exterior angles, alternate exterior angles, and we have shown that they are going to be equal. Now what we want to do is we want to determine the measures of angles A, B, C, and D. So we're going to use all of the properties we have learned, and we're going to find these measures without actually using a protractor and measuring. So what we can do, if we want to start with A, look at what kind of angles those are. They are corresponding angles. They are both below their relative parallel lines and to the right of the transversal. So angle A is going to equal 110 degrees. Angle A and angle B are vertically opposite angles. We know vertically opposite angles are equal. So angle B is going to be 110 degrees. If we look at angle A and angle C, these are between these two parallel lines. So these are interior, and they're on the same side of their transversal. Same side interior angles are supplementary. So that means they add to 180. So angle C is equal to 180 minus 110, which is 70 degrees. And then angle C and angle D are alternate interior. They're in between these parallel lines on opposite sides of the transversal. And alternate interior angles are equal. One side of a cell phone tower will be built to show. Use the angle measures to prove that the braces CG, BF, and AE are parallel. So we want to prove that these are parallel using the angles that are shown. Now there is more than one way to write this proof. There are different types of angles that you could choose to use. There are alternate interior, there are corresponding. So just so you know, there is more than one correct answer here. What we want to do is we want to prove they're parallel. So we want to show that the properties we have determined hold true in these situations. So one of the ways we could do it, one statement we could show is that angle DCG is equal to 78 degrees, and angle BAE equals 78 degrees. So angle DCG is equal to angle BAE. And that is a given fact in the question. We are told they're 78 degrees. Because those are corresponding angles, we have corresponding angles for AE and CG, and they happen to be the same. So therefore, we can say CG is parallel to AE. And we can state that because the corresponding angles are equal. So the lines are parallel. Because if you have two sets of angles that are in corresponding positions and they are the same, the lines must be parallel. So we've shown CG parallel to AE. Now, to show another set of these lines parallel. And again, there's more than one way to continue. But what we have here, we want to look at these two. we've got this angle is 35 and this angle is 35. So we can say that angle CGB equals 35 degrees and angle GBF equals 35 degrees. Therefore, angle CGB equals angle GBF. And this is given in the question. All right, there's nothing we had to do there. It's simply given. But because these are alternate interior angles, we can state that CG is parallel to BF. And the reason is alternate interior angles are equal, so the lines are parallel. And therefore, we can state that CG is parallel to BF, which is parallel to AE. And we can state that because they are all parallel to each other, so they must be parallel. If you're looking at it, both of them use CG, so therefore all of them must be parallel. AE, we can formalize it by saying AE and BF are parallel to CG, so they all have to be parallel. So key ideas. When a transversal intersects two parallel lines, these things occur. The corresponding angles are equal, the alternate interior angles are equal, the alternate exterior angles are equal, and the same side interior angles are supplementary. The other thing we also looked at was vertically opposite angles are equal. It doesn't matter if they're parallel lines or not. And so therefore, if you need to know, or here's a need to know, if a transversal intersects two lines that give you corresponding angles being equal, alternate interior being equal, alternate exterior being equal, or same side interior being supplementary, you can therefore state that the lines are parallel. So these are useful in proofs. If you know one of those statements to be true, you can then prove that the lines are parallel.